Hello and welcome to Algebra 2, Chapter 2.7, and today we're going to discuss piecewise functions. So a piecewise function is just a combination of equations that are put together, and then depending on the x that you use, which equation that you will evaluate from. So here we have 2x minus 1. You're going to use that if x is less than or equal to 1, but if x is greater than 1, you use this other function. So let me show you how to evaluate them. Okay, so we have a different piecewise function up here. F of x equals, so 3x plus 2 if x is less than or equal to 3, or x minus 1 if x is greater than 3. And notice you can't be in both, because either you're less than or equal to 3 or you're greater than 3. You're not both. Okay, so if I want f of 0, okay, which one of these would be when x is 0? Would be the top one, right? Because the top one is for all x's that are less than or equal to 3. That includes 0. So I'm going to use the top equation. So this is going to be 3 times 0 plus 2. And you're just going to evaluate that. So it's 0 plus 2, which is 2. Okay, or the next one, if I want f of 3, so I just got to figure out which one to use. So equals to 3. It's going to be that top one again, because that's the one that equals 3. So I'm going to evaluate in the top one. 3 times 3 plus 2. And that's going to be 9 plus 2, which is 11. And for the last one, f of 6. Well, 6 is going to be in the bottom one because 6 is greater than 3. So for any x greater than 3, we use the bottom one. So we're going to use 6 minus 1, which is 5. Okay. So what you need to remember is depending on the x that you're evaluating for, you just need to pick the correct equation to evaluate in. Do not evaluate in every equation. You just got to pick the correct one that corresponds with those x values. So we're going to evaluate, and the other thing we're going to do is we're going to graph. So these are both lines. They're slope-intercept form here, both lines, but I only want to graph them for these certain x's. So really, it's like there's this divider here at 2 that on one side, on the left-hand side, we're going to graph one line, and on the right-hand side, we're going to graph the other line. There's several ways to do this. What I think is the easiest is to actually graph these with a table. So I'm going to graph the first one, y equals 2/3 x plus 2/3. And I'm going to at least start with the table, and I'm going to start at 2. So if I put in 2, I'm going to get 4/3 plus 2/3, which is 6/3, which is 2. But that is not a point on this line because this line cannot be equal to 2. But I started at 2 because that's going to be my boundary. So at 2, 2, I'm going to do an open circle. And then I want to do x's that are greater than 2, so I'm going to go to 3. And that's going to give me 2 2/3. So at 3, I'm at 2 2/3. And then maybe I go to 6. And at 6, that's going to give me 4 2/3. 6. Okay. The other thing you could do from your starting point is you could count your slope. So from my starting point, I could go up 2 and over 3, and I would be there. All right. So when you draw this line in, this line is only for x is greater than 2, so it only goes one way. Okay, so what it is you graphed half of a line. Okay, then we're going to graph the other one, negative x plus 1. And I'm again going to start at 2. So negative 2 plus 1 would be negative 1. This time, though, I'm equal to 2. So at 2, negative 1, that's a filled-in circle. And then notice this is still a function because that's going to pass your vertical line test. And since I want to do x's that are less than 2, I might go to 1. So negative 1 plus 1 would be 0. You could also count your slope. If I go 0, it's going to be 1. And then when you draw on this line, it only goes that way. And then that's your piecewise function. So you're graphing part of both lines. Okay? So a little note here is that you can have a piecewise function that resembles stair steps, and it's called a step function. Okay? Also called the greatest integer function, and it's the greatest integer function if the one on the right is the shaded in one. Notice it still passes your vertical line test because you got to open in a closed circle there. So it's everything from that whole number, that integer, down to the next one, but the next one is open because then it jumps down to the next one. So that's a step function in case you're curious. Okay, the last thing we're going to do now is to write an equation for this piecewise function. So there's two parts. Order doesn't necessarily matter, but typically you do the one on the left first and kind of work your way to the right. There could be multiple parts here. Let's call this f of x equals, okay? So I need an equation for this line. Well, I know its y-intercept is 2, and its slope, down 1 over 1, down 1 over 1, its slope is -1. So negative x plus 2, that's your equation line, if x is less than 0. So for all the x's that are less than 0, I graphed that line. The other one looks to have a slope of 3 over 1. Okay, so 3x, but a -3 if x is greater than 0. Because notice neither of them are filled in circles, and that's fine. That is the equation for that piecewise function. All right, we will cover everything else in class. Let me know if you have any questions, and have a great day.